This query takes 47 seconds. It ran fine last week. Nothing changed except the data grew. Here is what happened. Week 1, report query, 200 milliseconds. Sequential scan on 50,000 rows. Fine. Month 3, the table hits 2 million rows. The planner still picks a sequential scan. No one notices. Month 6, 5 million rows. Nested loop with 1,000 iterations. 12 seconds. Someone files a ticket. Today, 10 million rows. 47 seconds. The dashboard times out. Users complain. One index will fix this. 47 seconds down to 0.2. 235 times faster. Explain Analyze is not how you find slow queries, it is how you understand why they are slow. Stay to the end. I show the full workflow, find it, understand it, fix it. Explain versus Explain Analyze. Know the difference. Explain shows the plan. It does not execute the query. Safe to run on update and delete. Use it to check plan shape. Explain Analyze actually runs the query and shows reality. Actual rows, actual time, actual buffers. Always add buffers. Without buffers you cannot see I/O. The minimum for real diagnostics, explain open parenthesis analyze comma buffers close parenthesis. Look at the output. Estimated rows 15. Actual rows 12. Close enough, statistics are good. But the execution time, 847 milliseconds. Sequential scan on the orders table. Rows removed by filter, 9,999,000. It read the entire table to find 12 rows. Shared read 127,000 pages. That is disk I/O. Shared hit 812 that was in cache. The read number is the problem. Danger, explain analyze executes the query. Wrap update and delete and begin, rollback. Reading and execution plan. 4 things to check every time. 1. Row estimates. Compare the estimated rows with actual rows. If they differ by 10 times or more, statistics are stale. Run analyze on the table. 2. Scan type. Sequential scan on a large table with a selective filter is a problem. Missing index. But sequential scan returning most rows is normal, do not blindly add indexes. 3. Join type. Nested loop is great when the outer side is small. Bad when it is large. Check the loops count. Actual time 0.01 milliseconds looks fast. But with loops equals 100,000, that is 1,000 milliseconds total. Always multiply. 4. Buffer I/O. Shared hit means the page was in shared buffers. Fast. Shared read means it was not in cache, could be disk. Temp read and write means sort or hash spill to disk. Increase work_MEM per session. Remember, cost units are arbitrary. Compare within a plan, not across queries. And sequential scan is not always bad on small tables or when returning most rows, it is faster than an index scan. PG_stat_ statements. This is how you find the worst queries. Create the extension. Add it to shared_preload_libraries and restart. Now it tracks every query, total execution time, calls, mean time, rows, and buffer hits. The top 10 query, select left of query 60 characters, calls, round total_exec_time divided by 1000 is total_SEC, round mean_exec_time is average_ms, rows, shared_blks_hit plus shared_blks_read is total_blks. From PG_stat_ statements, order by total_exec_time desk, limit 10. Sort by what matters. Total_exec_time for biggest overall cost. Mean underscore exec underscore time for slowest per call. Calls for most frequent. Shared underscore BLKS underscore read for most I/O. Prioritize by impact. A query running 10,000 times per hour at 50 milliseconds equals 500 seconds of total database time. More impactful than one query at 5 seconds. Reset periodically with PG underscore stat underscore statements underscore reset. PostgreSQL 14 and later normalizes query text where ID equals $1 groups all parameter variants. PG underscore stat underscore activity for what is slow right now. Auto underscore explain to catch slow plans in production logs. PG underscore stat underscore activity, select PID, now minus query underscore start as runtime, state, wait underscore event underscore type, wait underscore event, left of query 80 characters. Filter where state equals active and runtime over 5 seconds. The wait underscore event column tells you why it is slow. Data file read means the table needs caching or an index. Lock means contention. Client means the application is slow to consume results. Auto underscore explain, added to shared underscore preload underscore libraries. Set log underscore min underscore duration to 1 second. Enable log underscore analyze, log underscore buffers, and log underscore timing. Now every query over 1 second gets its full explain analyze plan logged automatically. You do not need to reproduce the problem. For per-session debugging without a restart, load auto underscore explain, then set auto underscore explain log underscore min underscore duration equals 500 milliseconds. The overhead, log underscore analyze adds timing to every query. Start with a high threshold and lower gradually. Also set log underscore min underscore duration underscore statement equals 1 second in PostgreSQL.conf, no extension needed. It logs the SQL text of every slow query. 5 fixed patterns that solve 90% of slow queries. 1. Add a missing index. Create index concurrently on orders, customer underscore ID, order underscore date. Always concurrently in production, no write lock. 2. Rewrite non-sargeable where clauses. Before, where date underscore part year of order underscore date equals 2026. This cannot use an index. After, where order underscore date greater than or equal to 2026 January 1st and order underscore date less than 2027 January 1st. Sargeable. Uses the index. 3. Fix stale statistics. Run analyze on the table. For skewed columns, increase the statistics target, alter table orders, alter column status, set statistics 1000. 4. Increase work underscore MEM for sort heavy queries. Set work underscore MEM equals 256 MB per session. Avoids temp file sort spill. But work underscore MEM is per operation, not per query. A query with 5 sorts allocates 5 times work underscore MEM. Set per session, not globally. 5. Use partial indexes. Create index concurrently IDX underscore orders underscore active on orders customer underscore ID where status equals active. Smaller index. Only covers the rows you actually query. Live demo part 1. Find the slow query and read the plan. Left terminal, find it. Top offenders from PG underscore stat underscore statements sorted by total execution time. The winner, select O.star, C.name from orders O join customers. 48,000 calls. Average 847 milliseconds each. Check PG underscore stat underscore activity, PID 4821, running for 12 seconds, wait event data file read. It is reading from disk right now. Right terminal, run explain analyze buffers on the exact query. The plan, nested loop, actual time 847 milliseconds. Inside, sequential scan on orders. Estimated 10 million rows, actual 4,821. Rows removed by filter, 9,995,000. Buffers, shared read 128,000. The problem is clear. Sequential scan on 10 million rows to find 4,821 matches. 128,000 pages read from disk. It needs an index. Demo Part 2. The fix. Create index concurrently IDX_orders_status_ created on orders, status, created _at. No write lock. Run the same query again with explain analyze buffers. New plan, nested loop, actual time 3.6 milliseconds. Index scan using IDX_orders_status_ created. Rows, 4,821. Buffers, shared hit 4,838. All from cache. No disk reads. The sidebar tells the story. Before, 847 milliseconds. Sequential scan on 10 million rows. 128,000 page reads. After, 3.6 milliseconds. Index scan. All from shared_buffers. 235 times faster. 1 index. No query rewrite needed. The key insight, the sequential scan was reading 128,000 pages. The index scan reads 4,838, all from cache. That is the difference. 5 slow query mistakes every DBA makes. 1. Using explain without analyze and buffers. Explain alone shows estimates, not reality. Without buffers you cannot see I/O. Explain analyze buffers is the minimum. 2. Ignoring stale statistics. Bad row estimates lead to bad plans. The planner picks sequential scan because it thinks 15 rows match when 500,000 do. Run analyze after bulk loads or schema changes. 3. Writing non-sargeable where clauses. Wrapping a column in a function disables index use. Where lower of email equals something cannot use a B tree on email. Use expression indexes or rewrite the query. 4. Forgetting the loops multiplier. Actual time 0.01 milliseconds looks fast. But loops equals 100,000 means 1,000 milliseconds total. Always multiply actual time times loops. 5. Not using PG_stat_ statements. Without it, you only find slow queries when users complain. Enable it in every production database. Sort by total_exec_time to find the biggest wins. 5 tools covered. PG_stat_ statements to find the worst queries. Explain analyze to read the plan. PG_stat_ activity to watch what is slow right now. Auto_explain to catch slow plans in production logs. And the fixed toolkit, indexes, query rewrites, statistics, work_mem. Find plus diagnose cheat sheet, top slow queries from PG_stat_ statements sorted by total_exec_time. Currently slow from PG_stat_ activity where state equals active. Full diagnostic plan with explain analyze buffers. Fix patterns cheat sheet, create index concurrently for missing indexes. Analyze for stale stats. Set work_mem for sort spill. Check PG_stat_user_indexes for unused indexes. From 47 seconds with a sequential scan to 3.6 milliseconds with an index scan. If you manage PostgreSQL in production, subscribe and press the bell icon. Like if this helped. Save for reference. Next up, cheat sheet number 6, PostgreSQL locks and concurrency. Row locks, table locks, advisory locks, deadlock detection, and PG_locks. Dr. Ibrar Ahmed. PostgreSQL Deep Dives. See you in the next one.